morning, guys. Congratulations on not taking the advanced math test today. It's got to feel good. Of course, you will have to take it tomorrow or the next day, but that's okay. Look, we're on chapter 1. No way. This is stuff that you learned in Algebra 1, although harder than what Algebra 1 would go through. So let's give it a try. Okay. So, example 1, you can try with me. Or better yet, pause the video and try on your own. Give it a shot. Distribute. Remember to distribute that negative too and solve for x. So it's just kind of a light review of stuff to kind of get you warmed up in this chapter. Okay, I'm going to try it. It's like I'm distributing a -1 here. So this is 6x minus 12 equals 7 plus a -x minus 5. I'm going to put this stuff together on this side. And then I'm going to try to get the x's on the same side and the numbers on the other. It really doesn't matter which side you decide to put the x's on. And if you did it right, you should get 2. Remember, you can always check on an extreme situation like a test or an ACT when you're confused about something. You can always plug it back in, see if it works. All right, this one's going to be a little harder. Remember, to combine stuff, you're going to want to make a common denominator. So what's common between 3, 2, and 4? Let's see what they all go into. 12. So I'm going to multiply this first one by 4 to get to 12. Multiply this one by 6. This one by 3. And this one by 4. So if I distribute it, I get 8x plus 16 plus 6 over 12. X, right? Yeah. And that equals 3/4 x, or 3x over 4, minus excuse me, 28 over 12. Oops, and that one should be over 12 too. Where did I put my... Probably downstairs. That's not good. Well, I guess I'll just scratch it out for now. Okay. So now I'm going to combine everything on top. That's 14x plus 16 over 12 equals 3x minus 28 over 12. And then to get rid of the 12s, I'm going to multiply by 12 on both sides, and that should cancel out those 12s. So now I'm left with just 14x plus 16 equals 3x minus 28. All right. And then I'm going to get everything on the same side. Like that. Okay, now there are some problems that we're going to talk about where you end up with no solution or infinite solutions. So I just wanted to do a quick one of those each. So here I've got negative 2, x plus 4, in parentheses, plus 3x equals x minus 8. All right, distribute like normal. End up with x minus 8 equals x minus 8. And then if I move the x's, I end up with negative 8 equals negative 8. So here's the rule. If you end up with a number equals a number, and you don't have any variables left, and they are the same number, that's important, they're the same number, that means that there's infinite solutions. Because no matter what you put into that problem, you will always get the same answer on the other side. So if I put in like 8 here, and 8 there, and 8 here, it would all work. If I put a million there, and a million there, and a million there, it would still all work. Infinite solutions. Example 4. Let's do this one. 3 times 3x minus 1 equals 9x plus 7. So if I distribute again, I end up with 9x minus 3 equals 9x plus 7. And subtract the 9x on both sides, I get negative 3 equals 7. So here we have another problem where we end up with a number equals a number, but they are different numbers. And the variable went away again. So this is no solution. That means no matter what number you tried in there, it would never ever work. So that's how you know the difference between a regular solution problem and a non-solution problem. Okay. So I guess one more we'll do is solving a formula for a specific variable without actually solving anything. So let's say that you had the problem a minus p equals PRT, and we needed to solve for p. This is the last one, almost done. So this is a technique that's used a lot in advanced math and other things. And basically what we're going to do is we're going to put all the stuff with p on one side to start with. So a equals, add p to both sides. That would be p plus PRT. Make sure that you don't try to actually put those together, because a p and a PRT can't go together. If it was like a 5 PRT and a 1 PRT, you could put them together, but they don't have the same variables, so you can't do that. All right, now what we're going to do is we're going to factor out that p. So you're left with 1 plus RT left. And then we're going to divide both sides by 1 plus RT. This strategy is used a lot in advanced math. So you end up with a over 1 plus RT equals p. Okay, so let's try some homework. And this is due on, what is today? Tuesday? So Tuesday, Wednesday, Thursday is when you guys are taking the test. So this is due Friday. We're going to have 2 assignments that are due on Friday. And this is one of them. Let's do page 92. Numbers 12 through 48. And we're going to do multiples of 4. So that's not that many problems. So the first problem would be 12, second one would be 16, then 20, then 24, etc. On the problems for, let's see, that would be 31 through 36. Looks like this.